starting with stacks. Now, as you can see, this pile of books. So until and unless we are submitting an assignment or so, what we will by default add a new book to the top of the pile. So that's what we basically do. So if you want to, for example, remove this orange book from here, so we cannot directly remove the orange book from here. Ideally, we will first remove the blue book, then the yellow book, then the dark blue, and then we can remove the orange book. So we just cannot insert an element, insert a book at any random position. Neither we can remove the book from any random position. Yeah. So what we basically do is insert at the top, that is add a book at the top, and remove a book from the top. Yeah. So that is basically what the concept of stacks is. That is the insertion and deletion of an element from a stack takes place from the same position. So talking about the features, it is linear, and stack ADT is widely used. It is used in many applications. We'll be talking about the application soon. It also follows LIFO principle, as I currently said. So last in, first out. That is what LIFO stands for. So the element which is inserted last will be the element which will be removed first. So insertion in stacks is called as push, and the removal of an element is called as pop. So we basically push the element at the same index. From there, we'll be popping the element. So that this is how it works. Talking about the advantages, now this LIFO principle, as we have seen in our previous data structures, it is not possible in arrays and lists, pure arrays and lists, because we'll be implementing stacks using linked lists. We can also implement stacks using arrays as well, but talking about pure arrays and pure lists, it is not possible. LIFO principle is not possible. Adds new element without overhead. Now, what is overhead? For example, you want to go somewhere out, so you might take a bike to go out. But if you just want to go somewhere which is 10 meters from your home, you won't take a bike. So that is extra effort for doing something. So that is basically the layman definition of what overhead means. You are doing something really extra, yeah. But in case of stacks, when you are adding a new element, you don't need to worry much, because you know where to insert the element. That is the exact position that we'll be inserting the element always. Okay. And also you use this stack data structure to solve various real world problems. We were talking about that. Now disadvantages, it can't be used everywhere, yeah, because of another disadvantages, that is it is less flexible to execute. Now stacks are like, you will insert an element from this position only and pop the element from this position only. So this is kind of not so flexible. You cannot use it everywhere for your like all of your programs. So it is kind of stiff. Yeah. So and element existence check is linear. Now, as we talked about, we'll be talking about the linked list implementation of the stacks. So if you want to check whether an element is present or not, so that won't be taking constant amount of time, yeah, because you need to move through each element one at a time. So again, so that is basically a linear time function. So element existence check is linear. Okay, so now moving on to the structure of a stack node, it is quite same as we talked about in case of linked list. So it has this data variable. It has a pointer to the next node. Also, we have initialized the top node to null. Top is basically the head of a linked list. So yeah, to just give it a different name, nothing else. And this is what the structure of a stack node would look like. Then we'll move to initializing a stack. Now, uh, yeah, so we have this create stack function. Okay, so it will be passed ELE. ELE is basically the data at which we want to store inside the stack. So we are creating this stack, creating it, not just initializing the stack data structure. So what we basically do is again create a temp variable. Now temp will be of the struct node type. So we are allocating the memory of struct node using this malloc function. We are entering the data, that is temp ka data, as the element or the number which is or any data which is passed to this function, which will be provided as an input. And for now, we are again saying temp connect should be null. Now over here, like we did in linked list, we actually returned this temp, but in this case, we don't need to return this temp because we know we are going to insert at the top position. Yeah. So if the list is empty and we have called this create stack function, yeah, because we create a stack only if the list is empty. So what we basically do is top equal to 10. So you have your first element of the stack. Moving on to the push operation. Now push operation in stack is exactly same as inserting an element at head position in the linked list. So what the basic concept of this insertion and that is pop and pop is push and pop is we're going to insert an element at the head position and we're also going to remove the element from the head position. That's all we're going to do. So in this push operation, we have again this declared temp node allocated the memory using malloc function. The temp ka data will be the value which is passed, and temp ka next will be the current no current top position. Yeah. So this is non. Then we do top equal to temp. So now the new top variable will be the newly created temp. Yeah, because we always insert an element at the 0th position, that is the top position. So top equal to temp, and we have also adjusted temp connects equal to the previous cutoff. So this is this we are done with push function. Now moving towards the pop function. Now pop function will basically the delete the pop the element at the head position, that is the top position in case of stacks. So first of all, we see if top is equal to null. Now when top will be equal to null, that means the stack is empty. So if the stack is empty, we definitely cannot delete an element. We cannot remove an element because it has nothing. So we just print stack underflow. Stack underflow basically means you're done with all the elements in the stack and you just cannot delete any other element. You cannot move behind. And then we return some huge number because basically what we do in pop function is return the value which we have deleted. So since we haven't found any value, since we don't have any value, we return a very big number. Then we move to the next part, that is if the top is not equal to null, that is we already have a stack. What we do is we declare a temp variable. So temp will be equal to top, as we have said over here, because we want to delete the top element, right? Because the pushing and popping takes place at the same position. Then what we do is collect the data which is stored at that position, that is the top position, which is currently our temp variable, in the variable I, because at the end we want to return I, and what we are doing is popping. So we are popping the top variable, so we will actually lose the entire top node. So, but we want to return the data as well. So we are currently storing that data in variable I. So now what we do is top equal to top next, because we are deleting the top element. So the new top should be the next element to the current top element. Then what we do is we free the temp variable. Now what temp consists of is the previous top variable, the previous top node. So we delete that temp variable using this free function and then return the value which we have previously stored if I vary. So yeah, this is all about the push and pop functions. Moving towards the is empty is again very simple function. What we basically see is if top is equal to null, that is there is no top element, no top elements. But we don't have a stack, so we return one indicating yeah that's true that the list is that the stack is empty. Else we return zero, that is the stack is not empty. Then we have a display top function, which is again very simple. All we do is just print the value which is stored at top. So if top is equal to null, that is if top doesn't even exist, so we again stay stack over underflow, and then we just return. Else we print the data which is stored at the top, and then we return. Okay. Now stacks across languages. Now talking about C programming language. C programming language doesn't have this inbuilt stack data structure. So as we have seen, we have implemented stacks using linked list. We can also implement stacks using arrays. You can definitely try it out. So we also have in C++ programming language, you have this stack data structure inbuilt in a standard template library. So yeah, you can definitely use that stack data structure using the standard template library, and it has lots of built-in methods, so you can definitely explore that thing. Stacks in Java, same. There exists a subclass of vector class. So inside that vector class, you have that LIFO stack. Okay. Talking about the applications now, undo redo operations in a text editor. Suppose you are typing something. So what needs to be undone is what you have currently typed. Yeah. So currently typed, matlab currently inserted. That exactly is what you need to undo. So this is the idea of stacks inside the undo and redo operations in a text editor. Then backtracking problems. Now this is again a famous algorithmic question. Introducing your guys with it briefly. So we are solving a Sudoku problem. So you insert the number 3 as the first row. Then you find out that no, that is not the position which is fit for the number 3. So what you do is after solving all that Sudoku, you come back again to that position where you have inserted the number 3. So that is you backtrack to that position where you have that number 3. So this is basically an idea, a rough idea of what backtracking problems are all about. Then you also have this recursive function calls in computers. Now I hope you all know what recursion is. So suppose you have a recursive tree, the last recursive call will return first. Yeah. So for example, you are computing some factorial. Yes, using recursion. So what you'll do is 5 into 4 into, for example, you're computing 5 factorial. So what you'll do is 5 into you'll call the recursive function for 4, then you'll call the recursive function for 3 until you reach 1. Yeah, because you actually know the value of 1 factorial is 1. So what you do is return 1 first, and then return 2 factorial, then return 3 factorial. So this is how it works. The function which is recently called is the one which will be returned. So that is again one of the applications of stacks. Now it is also in industrial applications. We use stacks for expression evaluation, parenthesis matching. These are again some famous algorithmic problems. You can definitely search about that. Now, expression conversion, that is infix, postfix, prefix. I think you might have heard about it. If you're coming from comms and IT, you definitely would have heard about this. And then again, you have memory management in compilers. It again talks about stacks. So if you have implemented a recursion, and suppose it is an infinite recursion, so you might have seen that error popping up, stack overflow. So that is basically the idea, the all the functions. And if you know about objects in C++, Java, and all that thing, so all these objects and functions, all these are basically stored inside stacks. So yeah, this is the basic idea, that is it is used in memory management.